As the introduction said, I lead the user services group here. We've been running Lustre on a lot of our systems for quite some time, and Sean introduced the team members who are here. Christopher is here, Chris Cox is here, and Haisong back there. But a lot of us involved in supporting the systems here. So quick outline of my talk. So I'll start off with some of the system architectures for the systems mentioned, and look at Expanse in particular from the performance standpoint. Talk about some of the tools we have for monitoring the file system usage and what some of it was in-house developed. And look at a few application examples. We have a pretty broad range of applications we support. So that's kind of the outline. So we provide, SDSC provides computational and data resources and services and expertise for a lot of the NSF systems. So 3 in particular that I'm talking about today. 2 of them are NSF systems, and 1 is an UCSD cluster. So first system I'm going to talk about is Expanse. It's about 100,000 cores of AMD ROM. IB connected, and it's in its 3rd year of operation now. Broad range of application with over like 40,000 users if we count all the users coming in through the gateways. And the predecessor for that was Comet, which has Intel Haswell processors. This actually had a long stint as an NSF resource, and once it was retired, it's been kind of repurposed to support researchers with the Center for Western Weather and Water Extremes, the CW3E. So it's a lot of cool applications there, and I'm going to talk about what it's used for in that context. And then the TSCC cluster is our campus cluster that essentially supports research computing for the UCSD campus. And all these systems, the Lustre file systems, are an important component of the I/O infrastructure, and really have been versatile enough to kind of support the various workloads that that we have. So in terms of systems, Expanse is a roughly 5 petaflop system. We have 14 scalable units. The crossed out 13 is because we started out with 13, and we've been adding racks to that. And it's a mix of standard compute nodes, which are essentially 2-socket AMD nodes with 128 cores each, and 52 GPU nodes. The Lustre file system is a 12 petabyte performance storage from Aeon Computing, the hardware. And as I mentioned, we have a wide range of scientific applications we support with that. And this is a category 1 capacity system supported by NSF. So it's a heterogeneous architecture. What we did is set it up with a bunch of scalable units. So each scalable unit has both CPU and GPU nodes in them. So we have basically 56 compute nodes and 4 GPU nodes in each. And within a rack, there's full bisection bandwidth connectivity. And then between racks, we have a 3:1 oversubscription. So that's kind of the network setup. And the Lustre file system connects into the IB fabric. So as I mentioned, basically 56 compute nodes and 4 GPU nodes, and it's 1 HDR switch with HDR 200 with 30 ports that we basically double into 60, 100 gig ports into each node, basically. So one into each node. All of this infrastructure also connects into our external connectivity via Arista switches, core switches, that we are actually in the process of upgrading right now. So that's kind of the overall system and the network architecture. Then the Lustre itself, we designed it to kind of address some of the performance bottlenecks we typically see. with this breadth of application cases, we see a lot of different types of operations. Like you'll see big block I/O with large scale parallel I/O kind of scale out kind of thing, but you also see a lot of small file I/O with lots of people writing little files continuously. So with that in mind, we looked into doing all NVMe MDS and then do a data and metadata for the smaller files to hopefully help with these small file situation. And we have a single file system with 2 mount points, one for projects and one for Scratch. So the Lustre architecture itself, it's hardware provided by Aeon, 12 petabytes of raw space, file capacity of about 3 billion files. The target for this was 140 gigabytes per second and about 200K in IOPS. And we are doing D&E phase 3. And some of the technical details I might not be able to answer, but I think Haisong back there can give you more details if needed. Right now we're running Lustre 2.13.0 with ZFS 7.13, but I think we are in the middle of going to upgrade that now very soon. Overall, it's 18 Lustre OSSs with 500 gigs of memory each, and IB HDR going into that, and 4 Lustre MDSs. And all of this go basically into a switch that's then connected into the IB fabric. So that was Expanse. And on Comet, this is the predecessor to Expanse. It's about a 2 petaflop system, and as I mentioned, it's Haswell processors with FDR InfiniBand. And this has about a 7, actually I think I should correct that. That should be 12 petabytes of Lustre now. That was the original setup was 7.6 petabytes, but now we have a new Lustre file system, again from Aeon, which is pretty much very similar to the Expanse Lustre file system with 12 petabytes raw. So the network architecture is a little bit different from Expanse. It's basically 72 nodes in a rack, and we have 18 links going out to a mid-tier InfiniBand switch, and then all of that goes into a core IB switch. And the Lustre is actually connected into the core IB. So here we have a 4:1 oversubscription going out between racks. Within a rack, we have basically 7 36-port switches set up so that we have full factory within a single rack. So we've always done this kind of island architecture where within a rack we've given lots of connectivity, and then between racks a little bit oversubscription. And with the user base that we support and the kinds of application we support, this has worked out pretty well. Like, we don't usually have bottleneck issues in terms of applications. So as I mentioned, Lustre is almost identical to the Expanse one with 12 petabytes raw. The only difference is in the MDSs. We have 2 MDSs with SSD based, and it's right now D&E phase 1. And data on metadata MDT here too. And as I mentioned, it's connected into the director switch. Slightly newer version of Lustre there compared to Expanse and ZFS 2.1. So the last cluster I want to talk about is the TSCC cluster. This is a Triton shared computing cluster. This is the primary HPC system for the UCSD faculty and researchers, and we kind of have a setup where we have some nodes that are pre-purchased by SDSC for like a hotel type access, that is you pay as you go, and then some that are actually bought in by the faculty and then added to the cluster. So it's a combination of a condo and a hotel essentially. The interesting thing here is actually this is basically there's a subset of nodes with IB, but most of it is actually 10 gigabit network interface, which is going to be upgraded pretty soon also. And it's Ethernet-based Lustre here, so that's a different thing, and it's worked out pretty well, I think, for the campus cluster. In addition to this, we also have a DDN Lustre that was set up for a particular group that was doing special data processing with dbGaP. So that's only mounted on a subset of nodes. So as you can see, between all these systems, we have a lot of Lustre out here at SDSC. So performance-wise, starting off with Expanse, basically our acceptance tests included both bandwidth and metadata requirements. So the bandwidth, we tested using IOR, and we did the simple thing to maximize it. Basically, 18 nodes, 8 tasks per client, so total of 144. And if you remember back, we had 72 OSDs, so it kind of works out that way. We had a aggregate file size of about 27 terabyte written in this test, and we hit our mark of, we had to hit 140, we went over that. For metadata, we used MD test, I think, and the IOPS we got were over the 200K that we needed to hit. So going to Expanse usage monitoring. So one of the things we quickly figured out with Lustre is we really need to know who's hitting our file system and where the load's coming from, and like dynamically be able to track all this so that we can chase down issues if needed, load-related issues. So one of the things that, and we did some things in-house, basically looking at the MDS changelog. There's a process called PDM that we've developed that basically collects the data from the changelog, and it's being periodically scraped by Prometheus, and then all of this kind of feeds into a Graphite instance with a Grafana front end. And also we have Telegraph running on OSS and MDS nodes to forward some other stats into Graphite. So all of this kind of is available through a Grafana front end, and what we do is use it for monitoring the system health, so the systems groups looking at it. But also from my team, the user services staff are usually looking at it because it's a quick way for us to figure out like anomalous workloads or somebody doing something totally crazy, like opening 20,000 files per second. That kind of stuff happens. So we try to spot that as early as we can and address it. So just some snapshots to show the kinds of things you can pick up. So here we have the MDS load, OSS load. Sometimes this alone is enough for us to figure out if something's going on. Like if there's a huge spike, it usually means someone's pushing the system really hard with IOPS or some kind of workload that drives the load up. And that's a cue for us to go find that source. But we also have the zpool data, the writes, reads. I just have the write snapshots here. And this is something we can actually query going back, so that's really helpful. Sometimes if we have a problem in the middle of the night and we wake up in the morning and look for things, we can actually still go back and identify the user who might have caused it or track down who the source of the issue. There are lots of system level things also being monitored. So you can look at this plot where we are showing the cache hits and cache misses on the servers. So that also is helpful to kind of foresee some of the problems coming up. So I mentioned that, but then there's on the user side, we can actually look at user info too. So this is a snapshot of the file opens per second, and you can see the pattern here. It's like around 4 to 5K files being opened per second by the same user. So the color code here is a particular user or a group. So this usually is not a problem. I mean, if it's periodic like this, but just a sense of what's going on. If I have to think about this is probably a user who's doing snapshots every at some frequency and, write from all 4,000 cores that they're running on. That's usually how you end up with this kind of file open. But sometimes this becomes continuous and it's at 20,000 or 25,000. That'll get us excited and go look for users to find out what they're doing. So you can track all kinds of things, changes, various groups. We can find out actually where the load's coming from, the host names, so you can actually go track down the job that's doing that. Why all this? Because people do trigger issues on Lustre. So what we've seen from the runs that we look at, usually it's because it's sustained metadata intensive activity. So some users have workloads that just generate a lot of scratch files, and there might be codes that do thousands of files per core, and they're always doing this continuously. And Lustre can handle this at this short duration, a few hours, but if you do this for like days on end, it has caused issues for us. So that's typically what we try to identify, and we've solved this locally by a combination of using NVMe local scratch for that kind of I/O, and then aggregate that into large files in Lustre if really it's needed. And we provide the scripts to the users to kind of do this. The other things that trigger these sort of issues, like IOPS heavy reads. Like for example, people might do like full Anaconda installs in Lustre, and when you initialize that, you'll hit every file. So you get like a 25,000 file spike, which is again fine if it's only once, but there are some workflows that repeatedly do this, and then that can cause issues. So with this, we've actually found that directing this to the DOM locations has sped up access and actually minimized problems. So this we've done quite a bit on comment. So that's one use case where basically we could actually use Lustre features to get around it. We've also had some issues which are probably specific to Lustre and ZFS together, but usually like upgrading, patching has helped. And again, if you want details on the sort of problems we see, I think Haisong can give you some of the background on that. So that's kind of the, the Lustre setup and kinds of things we do for monitoring, and what we do for helping out users change workflows if as needed to work better with Lustre. What are the kinds of applications we support? So it's a huge thing. It's a kitchen sink, basically, because right now, I think you think of a field, academic field, they use computing. So this is a big change for me. Like when I first started at SDSC, it used to be like, the usual suspect, like weather codes, astro codes, chemistry, and so on. Now it's everything. Lots of bioinformatic workloads, computational chemistry, engineering, and so on, but we also have lots of NLP, new workloads that are in social sciences, and different I/O patterns. So, and in terms of usage, we've used over 3.4 petabytes of the storage on Expanse in the first few years, and we have about 700 million files, I think. All kinds of I/O patterns, high throughput and jobs with continuous I/O from each job, those sort of things, or you might have large scale parallel I/O, file per task type I/O, and this can be also very different even within that. Like some have very large files, like there could be restart files that are written in really nice fashion with large blocks, which do very well on Lustre. Or you'll see something like, for example, OpenFOAM does file per core, per variable, per time step. So you can get 20 million files in a single run if you are not careful. And again, these are applications where there are options to do the right thing, but sometimes users are not aware of it and they just turn on the wrong thing. So we dealt with all kinds of I/O patterns. And over 3,000 researchers, over 400 institutions just logging in directly have had Expanse accounts, and then we have thousands more, tens of thousands more coming in through the science gateways, which also kind of run on our systems. So I just have 3 examples of users who actually run with a lot of Lustre. I mean, I think over 10 terabytes used in each of these cases, I think. So molecular mechanism of epigenetics. This is a lab at Illinois Institute of Technology. It uses Expanse to study these at the molecular level. And basically, it's a large-scale MD simulation, and they kind of examine the relation between the structures and gene expression. So they are huge Lustre users. Then we have data-driven intercomparison of storm resolving climate models. Thank you. And this is the Pritchett group at UCI, and they use the Expanse GPUs for this analysis. So this is basically combining the output from various climate models with training data from for variational autoencoders. So that kind of also involves a lot of data in Lustre that's read back. So the models that generate them, and then you read it back for all this training analysis. So all of those are Lustre intensive. And then we have our neutron star merger simulation. This is a traditional kind of heavy I/O workload. And CW3E, as I mentioned, is kind of very specific to that center. Comet's been repurposed for that, and their computations, they're looking at atmospheric rivers, precipitation, hydrology, sub-season to season simulations, community models, and so on. So all of this kind of is heavy data intensive. They, like, for example, their key project this winter was to simulate the storms that came through California. And they do near real-time forecasts. And so they run every night with data coming in from sensors, and then they make the predictions. And extremely intensive with almost 2 petabytes of data churning through for these. All of this on Lustre works perfectly. So just to summarize, Lustre is a pretty key component of our major clusters. Varying network architectures, Expanse and Comet, we have IB, TSCC, we are doing Ethernet-based. We have had pretty good performance delivery from both the file systems. And we have our own monitoring infrastructure that helps us monitor file system health and kind of predict I/O behavior of users and help out where we can to kind of better fit what Lustre's strengths are. And a huge variety of application workloads. So thank you, and I'll take questions.
Before we jump into the Q&A, there are 2 microphones at the front. So if you want to ask a question, please grab the microphone and pose your question. We will be running the microphones to you. You don't need to come down for that. Kai and Sean and I will be running the microphones.
Thanks.
Just raise a hand or something if you want to ask a question. Just raise a hand if you want to ask a question.
As usual, Peter has a very good suggestion. If you want to ask a question, raise your hands. We'll come and find you.
Thank you. I have a question about the Go program, PDM, that you said is watching the metadata changelog. How are you using that information? And I'm also curious what a typical rate of operations is, and do you ever have a problem with not being able to keep up and missing operations?
Yes. Oh, so high school.
Just a second.
Yeah, so PDM runs as an agent on a Lustre client. So file system is mounted on the node. So they're constantly talking to metadata, collecting information. Yes, sometimes the node is busy and the queue get piled up too much, so we set a cutoff to 100,000 queues. Once it reach that point, we shut down everything from collecting metadata information until somebody like me going there, intervene, resolve the load issue, and then then we continue the monitoring. So, yeah, it's open source. You can go to GitHub to get the PDM agent. So.
Before I hand the microphone, I think having an off-band telemetry system somehow embedded into Lustre or working with Lustre will be a great benefit for these reasons, flow control or just telemetry.
I think you had a question.
I was going to ask, I saw you said...
Yes.
I know.
Oh, there's one back there also.
Yes, I just had a question. You're using the data on metadata. Do you have any challenges managing user file usage on the metadata, like someone creating a huge number of files there and filling up your metadata system?
Not yet, but it might happen. So it's more used on Comet. I think on Expanse, we haven't really hit that hard yet because we still have to work with some of the users to actually push some things there. But on Comet, it's been used quite a bit for the Anaconda part that I was telling you. And we haven't hit an issue yet, I think.
My questions are straightforward. I just, early on you said you had a file system that was on a 2.13 release. I was just a bit surprised at that. Do you know, was it a particular feature or something? Why was there?
Maybe that's a question for Haisong.
I wonder.
As a reminder, if you are going to ask a question, please introduce yourself. Okay? We have a question.
Yes.
Let me run this up to Haisong because he's the man of the hour.
213 in particular.
He has the answers to the questions.
Yeah, the reason we run 2.13 was because at the time when we deployed Expanse, that was falling to that right moment when Lustre.org released 2.13, and there was a rumor saying that was going to be the long-term support version, but yeah, we'll find out that wasn't the case. So that's why we upgrading soon. So
Yeah, it's changing like next week.
yeah.
Hi, I'm Nick Thorne from the Texas Advanced Computing Center, and I wondered if you're doing any file system indexing and if that benefits or changes how sort of total user data management works, or what do you do when you hit 90% plus full?
No, we're not indexing at this point, right? I think that's not there. And but we are real far from 90% right now. We are at probably like 35-40% usage.
Right.
And we've been pretty aggressive with the purges, so it's worked out so far. We had that issue in our previous system, so we kind of learned from that and started our kind of limits very early, so we didn't get to that point.
You're probably going to want to keep the microphone, actually. If you want to hand it back to him. I actually have a question for Haisong. Hi, I'm Christian. I work at a company called OpenDrives. I'm just wondering what sort of issues you ran into with Lustre and ZFS, if there's anything sort of more specific or...
That's definitely
shared
a
experience. Yeah.
question, I think.
There are a lot.
That's a lot of.
There are a lot of
things.
issues we run into, but we can talk this offline
Yeah.
Sure.
during social settings and all that. Yeah, I'll be happy
I encourage the offline discussion. We'll probably need to jump to the next talk. Thank you.
Thank you.